Take a look at this diagram. As we get into Chapter 6, we're going to begin working with geometry in 3 dimensions. And it's really similar to the geometry we've been doing all year, except that we're going to begin involving other planes. So in this picture, there's actually several planes, but the ones we can easily see is plane N. It's the yellow plane that the 2 triangles are standing up on. There is the plane of triangle ABD, which is intersecting the plane of triangle ABC. So the 2 triangles are kind of standing up on plane N, leaning against each other so that they share a side, AB. And they want us to prove that AD is congruent to AC. So why don't you pause the video and try to do that. As you can see, it's the same steps we went through in the first semester. But now we're dealing with triangles that don't exist on the same plane. So that's what Chapter 6 is going to be about. So we'll work through some new terms, some new concepts in the video. We'll take a look at some of the new concepts as we apply them in a tutorial after the video. Okay, Ramblers, thanks for watching. Hey Ramblers, this video covers Chapter 6.1 in our textbook and deals with relating lines to planes. Now up to this point, the geometry we've worked on has dealt with 2 dimensions, but now we're going to talk about geometry in 3 dimensions, where we're going to have more than one plane involved. So after watching this video, you should understand what a plane is, find the 4 ways to determine a plane, and then be able to apply some vocabulary and 2 new postulates that deal with lines and planes in 3-dimensional space. Our Ramblers, thanks for watching, and I hope this helps. In Chapter 6.1, we learned to relate lines to planes to create geometry in 3 dimensions. So let's take a look at our building block of 3-dimensional geometry, which is going to be a plane. Now a plane is depicted like this, where even though it is infinitely wide and infinitely long, we have to represent it in 2 dimensions in a book or on a computer screen. So here's the convention we use. It'll look like a parallelogram, and that represents plane M. You'll notice that 2 of the sides will always be darkened to kind of show you that this is a surface. And then the other 2 sides will be a thinner line. We'll also have the name of the plane down in the lower corner or in the upper corner, but always a lowercase letter in one of the corners. Now, a plane can be named by a lowercase letter or by 3 points on the plane. Okay, now let's take a look at some vocabulary terms, or at least one of them. And the first is going to be a term we came across in Chapter 4, 4.5 to be exact, and that is coplanar. We know that if points, lines, segments, rays, so on and so on, if they lie in the same plane, we say they're coplanar. And if points, lines, and segments do not lie in the same plane, then they are non-coplanar. Okay, well, let's take a look at how we establish a plane, because that term coplanar may come up. I wanted to introduce it first. So there are 4 ways to determine a plane. The first is through 3 non-collinear points. Now, don't get non-collinear and non-coplanar confused. Non-collinear refers to 3 points that are all not on the same line, such as A, B, and C. Of course, AC would be on a line, or AB, but not all 3. If you come up with those 3 points, they can only determine one plane, and that will be plane M. Now you could come up with another point, maybe point E here, and that would determine a brand new plane that we could call N or something else like that. So any 3 points can determine only one plane. In this case, we have A, C, and B determining plane M, and A, C, and E determine another plane. You could also determine a plane using points E, C, and B. Can you imagine that? It would kind of be forming the back edge of this box. Also, A, B, and E could determine another plane. All right, let's go back to how we determine just one plane. So either three non-collinear points or a point and a line. The line cannot contain the point as C is not on line AB. That is another way to determine a plane. The third way is two intersecting lines. So line CD and line AB intersect at point P, and they determine a plane. Now really, this isn't very different than a line and a point not on the line, or three non-collinear points. Nevertheless, if you see two intersecting lines, they determine a plane. The last way would be two parallel lines. Two parallel lines also determine a plane. Okay, let's talk a little bit about another vocabulary term, that being the foot of a line. When a line intersects a plane, it does so at a point, and that point is called the foot of the line. So in this case, line QR is intersecting plane M at point P. Point P is therefore the foot of line QR. Okay, let's go back then and look at two new postulates concerning lines and planes. The first one says that if a line intersects a plane not containing it, then the intersection is exactly 1 point. Now, we just named that. So what this is saying simply is that a line and a plane, when they intersect, if the line is not in the plane, then the intersection is just 1 point. And as we just learned, the name of that point is the foot. Okay, let's take a look at the other postulate. The other postulate says if two planes intersect, then their intersection is exactly one line. So if this plane standing up, which we've called N, intersects plane M, their intersection would be this line, line CT, if you would. Okay. There are a couple of, there's actually one sample that I've included in the tutorial at the end, which will help you work through some of these new concepts, so I urge you to watch it. Okay, Ramblers, thanks for watching, and I hope this helps you with this new material relating lines to planes. Thanks for watching. Having watched the video, the sample problem number 1 on page 272 should give you some idea of how much of it you grasped. So let's go through them. For part A, they ask that the intersection of plane M and plane N. Well, of course you remember from the postulate that two planes intersect to form a line. So the intersection of M and N would have to be line AB. Okay, let's take a look at part B. A, B, and V determine what plane? Well, point A, point B, and point V are three non-collinear points, so they do determine a plane, and since they're all on the same plane, M, they determine plane M, as in Mary. Name the foot of line RS in plane M. Well, the foot of RS in plane M is going to be point P. Okay, in part D, AB and RS, they also determine a plane. And since AB and RS are two intersecting lines and they're both on plane N, they would determine plane N. Okay, letter E, AB and point what determine plane N? Well, line AB, and you could say point R or point S, because that would be another way of determining a plane, a line and a point not on the line. So AB is on plane N, and point R or point S is also on plane N. Okay, letter F. What does W lie in plane N? No, W, it's hard to tell, but W is on plane M. you can see that the dotted line, the dotted portion of line VW means that the line VW, or I should say the ray PW, extends behind plane N. So since we can't see it, it's dotted. So point W, and in fact ray PW, is on plane M, not on plane N. Okay, so let's take a look at G. Line AB and line what determine plane M? Well, we could say line VW, because those are two intersecting lines, and two intersecting lines determine a plane, since they're both on plane M. Letter H, A, B, and V, and what are coplanar points? Well, A, B, V, and W are all coplanar points. A, B, V, and what are non-coplanar points? Well, this is anything that's not on plane M. So we could say that point R or point S would be non-coplanar. So this is important, that even though A, B, and V are coplanar, there is, as soon as you have one point in the group that is not, then all four of the points are non-coplanar. Come to think of it, any 3 points are coplanar, aren't they? Think about why that's true. Okay, the last one is letter J. If R and S lie in plane N, what can be said about RS? Well, just that RS lies in plane N. Not very interesting. Okay, thanks for watching, Ramblers. Hope this helps.